Okay, here we have a problem. If f of x is e to the x quantity squared, find f of 0, f prime of 0, x if f prime of x is 1, and the tangent line at 0, f of 0. So I'm going to first take this function and write it over here as f of x is equal to e to the 2x. I'm going to use my properties of exponents first because I have a power raised to a power, so I know I can rewrite that as e to the 2 times x. That'll be just a little bit easier for me to work with. Now f of 0 is going to be e to the 2 times 0, which is e to the 0, which is 1. F prime of 0, well, let's differentiate. F prime of x is going to be e to the 2x times the derivative of 2x with respect to x, which is just 2. So all that does is put a coefficient 2 in front. So f prime of 0 then is going to be 2e to the 2 times 0. Well, e to the 0 is 1, so that's just 2. Now let's find x if f prime of x is equal to 1. So that implies that 2e to the 2x is equal to 1, which means that e to the 2x is equal to 1/2. Now I'll take the natural log of both sides, so I can solve this for 2x by getting the 2x to be a coefficient. So natural log of this is 2x, and natural log of the other side is natural log of 1/2. Okay, so I'm going to look at this real quickly here. This is natural log 1. Is that still on the screen? Let's go down here. So this is natural log 1 minus natural log 2. 2x is equal to that. Natural log 1 is 0, so this is 2x is equal to negative natural log 2. So x is equal to negative natural log 2 all divided by 2. And I think as a decimal that comes out to be negative 0.3466. Okay, next let's find the tangent line to this graph at the point 0, f of 0. Well, I know that f of 0 is equal to 1, so this is the point, x equals 0, y equals 1. So I'll use my point slope form of the equation of the line, and I'll have y minus y1 is equal to m, the slope at 0, which I've already found is 2, times x minus 0. So I have y minus 1 equals 2x. So y is equal to 2x plus 1. So there's the equation of the tangent line to this graph at the point x equals 0, y equals 1. So here's what it looks like algebraically to solve this problem or answer these questions right here. What I want to do now is take you to the computer and look at our Desmos graphing program and just see if we can't use Desmos to confirm these things right here. So let's go to the computer and take a look. So here's the Desmos program, and for the first graph I put in our original function y equal e to the x quantity squared, and you can see that in red over here. The second function is our derivative, y equal 2e to the 2x, and so that is this blue graph right here. And because it's the derivative, for any value of y on this graph, we get the slope of the line tangent to the other graph for the same value of x. Now for our other part of the problem, we wanted to know what is the value of the derivative when y is equal to 1. So I graphed y equal 1 right here, and I simply look on the graph of the derivative, and there's the point, negative 0.347 and 1, and that's approximately what we got when we did this algebraically. So next, let me put in the equation of the line tangent to the graph at the point x equals 0, y equal f of 0. And we found that to be y equals 2x plus 1. And sure enough, that's the black graph that you see right here, and it looks like it's tangent to our original graph at the point 0, 1. Okay, so you can see that when we look at the graphs of these different functions, we confirmed the work that we did here algebraically. So it's nice to see things two ways. We see it algebraically here, and then we also confirm it graphically using our Desmos graphing program.